Welcome back to the Save It for Parts channel. Today we're going to try to snoop on some US military satellites using random junk in my garage. Now if you've seen my channel, you know my random junk collection includes all kinds of satellite dish hardware. We've got these RV satellite dishes, we've got this old Wi-Fi dish, we've got this C-band dish from the 80s that someone gave me. And I've got this whole pile of other satellite-adjacent gear. I don't even know what some of this stuff does. I just obsessively hoard it when I find it at the surplus store, at auctions. Anytime I see cheap satellite hardware, I drag it home. What I want to try today is to download imagery from the US government's Defense Meteorological Satellite Program.
For the past 50 years, the Defense Meteorological Satellite Program, DMSP satellites, have fulfilled the military's most critical requirements for global atmospheric, oceanic, terrestrial, and space environment information. Through these satellites, military users find, track, and forecast weather systems over remote and hostile areas for deployed troops.
These are two satellites that remain out of an original constellation of quite a few other satellites. These have had some issues over their life. They had some flaky batteries when they launched these, so a bunch of them just exploded, and right now there are only two left. These were originally designed back in the 1960s, 1970s. They're very similar to the NOAA meteorological satellites that you've seen me mess with before on this channel. They're in a polar orbit. They come over any given location on the Earth about twice a day. And an interesting feature of these DMSP satellites is that they are actually encrypted for most of their orbit. They only unencrypt themselves when they're over North America, over the US, and then you can get imagery from these for free.
The primary weather sensor on DMSP is the operational line scan system, which provides continuous visual and infrared imagery of cloud cover over an area 600 nautical miles wide.
So our sensor is pointing down and sweeping back and forth 6 times a second, photographing the Earth, and then storing those images and transmitting them down to our ground stations once every orbit.
A very common question I get when I do weather satellite videos is this legal? And then the second most common question is, why aren't these encrypted? Well, most of the satellites I work with are publicly funded. They're from public agencies like the National Weather Service, like the National Oceanic and Atmospheric Administration, and they're made to be available for anybody, anywhere in the world. The satellites that I want to look at today are not supposed to be publicly available, at least not for most of the world. These are Defense Department satellites, these are military satellites, so they are actually encrypted for pretty much everyone else. If you live outside the US, then I'm sorry to say you might not be able to do anything with these satellites. So the DMSP satellite program originated in the 1960s, although the current satellites are a little newer than that. This was kind of a spy satellite for spy satellites. What I mean by that is the DMSP satellite would be a weather satellite, and it would go over first. So let's say it would go across Moscow, and it would say, what's the weather like? Is it cloudy? The actual spy satellite, like the Corona system, used film, and so they didn't want to waste their film if it was cloudy and they couldn't see the ground. So if the weather was nice, Corona would go over, it would take a film picture, and that would be the one that could see like Soviet license plates. So the film got spooled into a cassette magazine, something like this one, and that lived inside of a conical re-entry vehicle called a bucket. Once the bucket and film spool were full, the satellite would fly over US-controlled airspace, eject the bucket, that would re-enter the Earth's atmosphere, deploy a parachute, and then get scooped up by a CIA aircraft. Yeah, I don't know how many drugs the designers were on, but the 60s were crazy.
Beginning in 1966, it acquired a tactical as well as strategic capability and furnished the needed weather support for both activities. Indeed, DMSP significantly increased the image search system effectiveness of NRO reconnaissance satellites and of SAC SR-71 and U-2 reconnaissance aircraft, while it markedly reduced the number of aerial meteorological sorties. Declassified in 1972, DMSP data was made available to civilian and scientific user communities.
Anyway, nowadays our spy satellites are all digital, they don't have to use film, so the DMSP satellites are a little bit obsolete, but they still do get used for weather forecasting for military operations and things of that nature. These are on what's called the S-band of the microwave spectrum, around 2.2 gigahertz. Previously, we've looked at stuff in the L-band. That's what this little dish is set up for. That's around 1.7 gigahertz. S-band is a little more tricky. It's a little harder to find commercial equipment for that, although Wi-Fi is pretty close. Wi-Fi is around 2.4 gigahertz. Now, another thing I've heard that works pretty well for these satellites is this dingus called an MMDS, and this is apparently some kind of microwave point-to-point antenna that's common mostly over in Asia. They're not very common in the US, and you can't really find these in the US, so I've tried to find a few of these. I don't even remember where I got this one. Unfortunately, this one is tuned for 2500 to 2700 megahertz, not 2200 like I want. So this one I wasted my money on. This one I got from a website called AliExpress. Now, I've never used AliExpress before. I get the impression it's like a kind of sketchier, more communist Amazon. A lot of people that I know have good things to say about it, and a lot of people I know have terrible things to say about it. Some people say you'll get great deals, you'll get stuff for like a tenth of the price of Amazon. Other people say, yeah, it's a tenth the price, but it takes 8 months to show up and it's a box of sand when you actually get it. So I don't know whether or not this is actually any good, and I'm extra hesitant because there are absolutely no markings on this thing. So there are no specifications, there are no serial numbers. The antenna that is built into the MMDS is a linear feed, so this is just a little dipole. This is for radio waves that are coming in one direction. And most of these satellites that I want to look at use a helical feed or helical polarization, so the signal is coming in kind of a spiral. This is a feed I made a while back for S-band. It's using SGC Derek's design, and my 3D printer hates printing stuff like this, so I had to hack this together out of 2 failed prints. I think it maybe kind of works. So instead of this linear feed, I'm just going to put an antenna jack on there. I hope that's good enough. I'm really bad at soldering, so I may or may not have destroyed this thing. Yeah, I know that technically should be like an end mount or something, but all I have are these old CB parts, so this is the Save It for Parts channel. We use whatever I've got lying around. Alright, now that we have our magic wand or sonic screwdriver or whatever this abomination is, we need a reflector dish. This was originally a television dish for RVing or camping. If you absolutely needed to watch football in the 1980s, you'd take this thing out with your RV, you'd unfold it, and you'd really piss off your family by watching TV instead of enjoying nature. But people keep asking me, where do you find one of these? I have no idea. Another ham in the Twin Cities named Chandler gave it to me. I have never seen one again on any used websites. I've seen some modern day folding dishes like this from Earth Moon Earth Communications supply places, and there are no prices listed, which means you absolutely cannot afford it. We're not trying to fully deploy this in the garage. I just want to get to the focal point here, to the LNB or low noise block. We're going to remove that. Thing's a little heavy and a little floppy. We might have to reinforce it slightly. Now, the focal point on this is probably not going to be correct because the helix is kind of way out here, but I can slide this arm in and out, so if we need to move this farther or closer to the dish, we can do that later. Next, we need to figure out how to power this MMDS thing. Most of these devices, like low noise amplifiers, LNBs, LNAs, need some kind of DC voltage, and this just has one input, so we're going to need something like a power injector or a bias T to inject a DC voltage into the antenna line, and then we may need a DC blocker to keep that voltage from going back into our radio. Just a couple extra parts that are needed for this. I have some of that stuff lying around already. I don't actually know what voltage this wants. A lot of amateur level LNBs want 5 volts, but a lot of satellite equipment wants 14 to 16 volts. And this isn't even a satellite device. This is like I don't even know what this is. It's like Korean Wi-Fi or something. I looked up the power requirements. It looks like the MMDS wants 12 volts, so we've got an adapter for that. Then we're going to have to feed it somehow, so I got to dig through my other box of satellite parts and accessories and connectors and whatnot. Somewhere in here, I think I have just a bias T, just a little inline power injector that will give whatever voltage I want into the RF line. Now, most software-defined radios, like the rtl-sdr or the hack RF1, have a bias T built in, and they will feed voltage out to an LNA or another device, but usually these are only feeding 5 volts, and we need 12. Couldn't find the one that I thought I had, but I did find this other one. Looks like it needs some soldering first. Again, not a great solder job. I fully expect this to break at some point during the making of this video. I went on into.io.com and looked up a bunch of upcoming satellite passes. The DMSP satellites that I'm most interested in are kind of an inconvenient time slot. So we're using the Newelec HackRF1. We've got our bias T, we've got the power supply for the bias T, we've got that hooked up to the dish. Now the local oscillator in that MMDS dingus is supposed to be 1.998 gigahertz, so I need to offset SDR++ so that it's seeing the incoming frequency minus that local oscillator for the final frequency here. The HackRF1 can go all the way up into S-band by itself, but the MMDS is down converting anyway, so we'll just use that new frequency. So SDR++ actually has that as an option for the offset already, so it has that 1998 megahertz MMDS right in there in the drop-down menu. That's convenient. So to track the satellite, I use an app called Stellarium, which I absolutely cannot recommend. It is terrible, but it's the only thing I can find that actually gives me a heads-up display where I can hold the phone up in the air, and it gives me kind of an AR, augmented reality view of where the satellite is, so I can track and follow it. So I've got my phone velcroed onto the dish so we can use that heads-up display. I had Stellarium working for a moment. It has decided to crap out again. As the satellite passes overhead, I want to try to keep the dish aimed at it as close as possible. We're going to record the signal on the laptop, and then we will run that through SatDump later on and try to decode that. Okay, so my first try with this was a complete failure. I saw absolutely nothing, but my first tries with satellite things are usually a complete failure, so we're going to try again. Let's talk about orbits for a minute. Carl over at US Radio Guy has a great animation of how some of these different orbits work. So a geostationary orbit like the GOES satellite, which I've looked at before, is far enough away from the Earth where its orbit goes around once every 24 hours. So it is always centered above one spot on the Earth, and it always sees about 1/3 of the Earth's surface. When you space 3 of these satellites around the Earth, you get complete weather coverage. And there are more than 3 because other countries have different satellites up in similar orbits. Now, if we zoom in closer to the Earth's surface, we get low Earth orbit satellites, and specifically polar orbits. So these go around the Earth basically every 90 minutes or so, and they follow a north to south track. So on one side of the planet, they're going from the North Pole to the South Pole. On the other side of the orbit, they're going South Pole to North Pole. They are sun synchronous, so their orbit is pretty much always in line with the sun, and the Earth rotates underneath them. So during the course of the day, each satellite sees a slightly different track of the Earth. If you want to know more about satellite stuff, usradioguy.com is a fantastic resource, and Carl has all kinds of information over there, which has really helped me out, and I have recommended him to all kinds of people. So I'll throw some links to him down in the description below, and I'll throw a link to the original video here as well. With the low Earth orbit satellites, we have to track them as they go overhead, because relative to us on the ground, they're moving pretty quickly, and we get about a 10 to 15 minute window when they're directly overhead, and we can get a good enough signal to decode weather images. Alright, this is about the 4th satellite I've tried today, and it seems like we might be getting something, but it's not a very strong signal. And now it's raining, so I am absolutely giving up on this for today. At least the ducks are happy about this. Since I had some issues with the HackRF1, we're going to try the rtl-sdr this time. It does not have as much bandwidth as the HackRF1 and cannot go as high in frequency range, so it's not really as good for S-band, but if we trust the MMDS here, which I guess I kind of do, it seems like it's mostly working, then the MMDS should down convert from S-band to something that the rtl-sdr here can see. Okay, I think we've got this a little more dialed in. We're looking at Sirius XM satellite radio signals. We can't actually listen to the radio because it's encrypted, but we can at least see what the pattern looks like. We're going to give this another shot. We've got DMSP 18 just coming above the horizon. So we're going to try and track that, see if we can record it. I think we might have actually got something this time, and I think we might have seen where it went from encrypted to unencrypted. That was kind of cool. The signal changed dramatically. So let's run that through SatDump, see if we actually are able to get an image from it. I think we're synced now, so I think that was where it went from encrypted to unencrypted. So yeah, this is definitely more promising than last time. All right, we definitely got something from DMSP. It's not fantastic, but we definitely got some data from it this time. All right, we finally got some data on S-band from those military satellites. It's not great, I can't tell what it is, but we've definitely got an image, and this is a good start. It's only taken a couple days to get to this point, but now we've got something we can build on, and try to get a little bit more, try to refine our situation here, and hopefully get something recognizable. All right, I am up too early in the morning for this, but we've got another pass coming over, so we're going to give it a shot. It's also a very windy morning, so the big dish is just blowing around everywhere like a sail. I really need to set up a motorized tracking mount for these big dishes. It's been on my to-do list forever. We've got the geodesic radome for that out at Sandland, but I just have not gotten the motors figured out. Alright, well that pass was another complete failure. I saw the satellite for just a second on the SDR screen and then I could never lock onto it again. I was searching all over the place with that dish. So I went digging around in my satellite stuff box again and I found two more possible S-band antenna feeds that I could try out. We've got this thing, and then we've got this crazy thing that looks like something you give your kid when you're at the state fair. So if I haven't shown off the Nano VNA before, this little gadget basically is a portable antenna analyzer, and I really only use it for SWR to see what the standing wave ratio is, where is an antenna most optimized. Alright, so here's our loop feed, and we've put that in an old camping dish that I was going to melt down for the aluminum. So we've stuck that on here. We've got our MMDS converter, kind of the same as before. We've got this thing at the focal point of the dish. Hopefully the giant aluminum canoe there doesn't affect the signal. Maybe somebody can come up with a way I can make a canoe into an antenna, although I'm going to use that one as a boat. So yet again, another complete failure. Didn't get anything. So this contraption didn't work. Since my professionally made loop antenna didn't work, I made a worse one. So I've just got a random loop of wire. I've got my pie pan here. We'll try that next. That time we got a little more signal. I still was not able to decode much from it, but it's getting more promising. So we've got another DMSP satellite coming over. This is about 8 hours later, so this is not a fast process. All right, we finally got something semi-recognizable. I can see some of the Great Lakes here. I've woken up far too early to try another attempt at a decent DMSP pass. Normally I don't like to get up this early, but I'm trying really hard to get something good out of these satellites, and this is a pretty good straight overhead pass, north to south. We've been doing south to north. It seems like it only decrypts around 40 degrees north latitude, so it's still encrypted over the southern part of the US, and it's only in the clear for the northern part. I guess the southern US is secret, and the military doesn't care if anybody sees the northern half, so I don't know. Anyway, I'm not quite awake yet, but we're going to try to get the dish set up in the dark, get that next recording at about 6 a.m. here. I'm pretty sure the neighbors think I'm crazy. I think I'm crazy. Well, on the plus side, doing it this early means there's no annoying sun to get on the laptop screen, so no reflections. On the minus side, way more mosquitoes. Okay, so we got up before 6 a.m., we got the dish set up, tracked that thing over in the dark with the mosquitoes, and I got absolutely nothing again. So this one was DMSP F18. I don't know if 18 just isn't on right now, if it doesn't work going south versus going north. So we've got an upcoming pass with a relatively low elevation, and I'd like to try to get it. I'd also like to try to see over some trees, and then I'd like to be able to get kind of down and behind the dish so it's easier to track things. So, to overcome some of those issues, we stuck the dish up on the car. If my neighbors thought I was crazy before, now they know for sure. Alright, so the signal looks great for this pass, and we were able to decode several channels from the OLS system. We have the visible light channel, we have the infrared channel, which is not as interesting, we have the thermal channel, and then my favorite, a combination channel that SatDump puts together. I think this one looks the best. So at this point, I have tried listening to both of the surviving DMSP satellites, F-17 and F-18. They both have similar behavior. They don't seem to transmit anything on a southbound pass, where they're passing over me from north to south. They do seem to transmit on northbound passes, but they're encrypted for the southern 2/3 of the US, and then they switch to unencrypted somewhere around 40 degrees north latitude. So, very interesting. I don't know why that is. Some of this stuff is not documented, and you're not really supposed to be seeing these signals. It's not advertised that this is available to the public, but they do have that encryption turned off supposedly for passes over the poles for scientists to use, and then supposedly over the US, although it really seems to just be the northern third of the US and then Canada. We've brought out the tracking antenna situation again for a couple of reasons. First off, I'm a terrible antenna tracker. When I handhold the big C-band dish over my head, we didn't have much luck with it before with DMSP satellites, but I think that's because those were north to south passes, and the satellites aren't transmitting when they're on a descending pass, a southbound pass, at least over me, or at least not on a frequency that I know about. So we're going to try some northbound passes, but first we're going to try this on a known satellite signal. We're actually going to try some of the NOAA satellites. Again, this is an L-band helix on this thing, but I checked it with the Nano VNA and it has pretty good performance on S-band as well. We're going to give it a try. We're going to run it through that MMDS. As always, I use nothing but the highest quality DIY antenna components. I also do have to apologize as I'm throwing out tons of jargon here, and I say things like C-band dish even though I'm using it for S-band. This is an L-band dish, which I'm also using for S-band, but originally it was a 2.4 gigahertz or 5.8 gigahertz antenna. Anyway, I'm mixing what the original purpose of the dish was. I apologize if I'm confusing everyone. Feel free to ask questions in the comments, and if I'm not too confused myself, I will try to answer them. This really should be up right at the feed, but this thing is too flimsy for it. It would knock off my situation there. So it's down here. That is hooked up to the power injector, hooked up to the SDR. We are running G-Predict for the rotor control, which is controlling this little box over USB. That is controlling our pan tilt mount, which is originally for a security camera. All right, I think we're starting to get something here. It's not super consistent, but this might be the encrypted signal. All right, it just switched to unencrypted, so we are getting a very faint signal there. It's not as good as it was with the other dish, though. Yeah, SatDump says this is a garbage recording. We got nothing from that pass. So we're gonna put the little tracking dish aside for now, and we're gonna go back to the folding dish and try that maybe one more time. Since this is a morning pass going south, we probably won't get anything on the normal frequency, but I have a list of alternate frequencies to try that I found online, so we're going to check all of those. So despite Stellarium's best efforts, I did find the satellite using G-Predict to aim the dish. Very inefficient, but we did find it. I got a signal, looks like a regular signal, but it's on 2237.5 megahertz. And then it disappeared, so I don't know if it switched frequencies again. Yeah, tracking the satellite based on this screen is doable, but it is not as easy as the heads-up display. We're giving DMSP one more try, maybe the last try, depending on how this pass goes, because I am getting tired of this. So we're going to track this from south to north, same as before. You're all getting tired of seeing me do this. All right, so I was looking around the satellite bands, and I randomly found this coming down from space. Okay, so I don't think it's actually coming down from space. I think we're just getting a multiple harmonic of an FM radio station. But I did have some Star Trek movie vibes there. Here's some cell phone interference. This stuff is just polluting the entire microwave band. And supposedly the government is going to sell off even more of our satellite frequencies to cell phone companies. So pretty soon we won't even be able to do stuff like this. We'll just have to buy our satellite data from some faceless corporation. And so far, I think the best pass I've gotten out of these several weeks was when I stuck it on top of my car. So let's just do that again. Sure, this scratches the shit out of the roof, but it's just a car, and satellites are way cooler than cars, so I think this is worth it. All right, I think we got it. It was touch and go there for a little bit. It was really hard to acquire the signal. I tried this time just pointing the dish around, finding the signal and tracking it. I didn't use Stellarium at all. I did use G-Predict to tell me angle to point it, but it is still really difficult to find that signal and stay on target through the whole pass. So especially at S-band, you have to be really accurate. You have to get that dish pointed just right. So we're hitting the limits of what I can do as a human antenna rotor. So that was a decent DMSP 17 pass. got a decent picture from the Defense Department satellite. It's not an exciting picture, it's mostly clouds and stuff. They're not all that exciting. It's really, there's better imagery from NOAA, from Meteor, from other satellites out there. These are pretty obsolete military satellites. They're retiring them if they don't explode first, and they're replacing them with something new, which I don't know if I can receive the new thing, but we'll look into that in the future maybe. It was interesting to look at, it was a fun challenge to look at, but they're not exciting enough to really look at on a regular basis, at least not for me. So I have done a lot of wild goose chases during the course of this video. I have tried a lot of frequencies that turned out not to actually be active. I've tried a lot of satellites that turned out to not quite do what people online say they do. But that's all part of learning, and that's all part of this hobby, is trying things for myself, finding out for myself what is and isn't working. And this could all change. Satellites could shift frequencies, they could start doing different behaviors. So it's good to try it firsthand, see what's actually working at the moment, and to try different satellites to just verify, is my equipment working? Is my radio working? Do I have the right frequencies? Do I have the right procedures? And eventually, it all does start to come together and I start getting a little bit better imagery. I'm going to wrap this video up here. I hope it wasn't too boring. I had originally something around 4 hours of raw footage, and I've been trying to cut it down and keep it under half an hour. So a lot of stuff got cut, a lot of false starts got cut, a lot of dead ends got cut out, and I could probably do several videos just with the outtakes from this one. If you did enjoy the video and you want to help me make more videos like this, you can support me through Patreon or YouTube membership. That always helps with my experiments and it helps keep the channel going. And you can always click like and subscribe, which helps make the video popular and keeps me doing content like this. Check out some of the links in the description below if you want more detailed information about this project, and check out some of my other satellite videos if you're curious about other things I've done along these lines. Thank you to everyone for watching, and we'll see you next time.